For this module, we're going to take a look at gateways and trunks in depth. And this is actually going to be quite a long video. We're going to take a look. When I say in depth, I really mean in depth. So we're going to look at everything basically that we haven't covered yet in gateways and trunks. We'll look a little bit more at some specific DSP and PVDM information in a little bit later video. And then we'll take a look at using both DSPs and PVDMs for media resources, and then also for gateways and trunks as well, slightly after that. So first of all, taking a look at voice and video gateway hardware, we're going to take a look at some primary and special usage type gateways. So primary, we have our good old faithful ISRs, or integrated services routers. These are the 2800 and 3800 series of routers. And then the newer, although not really that new anymore, but the newer ISR G2s, or Integrated Service Router Generation 2. So these are the 2900 and 3900 series of routers. And then a number of special usage pieces. We've got something called the ATA 186. ATA is an analog terminal adapter. So it's a terminal or an endpoint that really doesn't specify a gateway per se. It's a terminal, meaning it's got one or a couple devices beyond it, but it doesn't really provide a gateway to a number of services, whether they be analog or digital telephony services. And what this does is provides two FXS ports. It's obviously got an Ethernet port for connection to a switch, as well as another and actually, this says ATA 186. I should have probably updated this to say the newer versions, the ATA 188s, but still two FXS ports, so connecting to analog devices or station devices is that S, foreign exchange station. And it's also got another Ethernet interface for a PC or something else that you might want to connect network-wise beyond the first network port for a switch. But the idea being that it's in a very compact form. I don't have one in front of me, but about that big. Oh, that's right, you can't see. No, probably about, I'd say 5 inches wide by maybe 4 or 5 inches in length, and then, or you might say deep, and then about probably about 1.5 inches or 2 inches max high. So very small form factor. Not necessarily the greatest for faxing or modem. Okay, in fact, not really ideal for that at all, but mainly provided, I think they can be used for that, but mainly for analog phones, you know, let's say elevator phone or a shop phone or something. Then we've got a VG248. There is also a VG224. VG248 provides 48 FXS ports, and a VG224 provides 24 FXS ports. Now, why would you want to get the 224? Well, first of all, it's a newer device. The VG248 is an older device. It has older DSPs in it, and so it can't quite reach some of the higher faxing speeds or modem speeds. In fact, if I remember properly, the 248 will only support modem speeds of up to 33.6, whereas the 224, by the way, the 248 is a proprietary OS, and it's a menu-based command line, whereas the 224 is actually just standard iOS. And, well, it's a specialized image, but looks just like standard iOS. And it has capability for up to V.90 modem speed, so up to 56K, as well as Super G3 faxing speeds. Okay, so the VG248 does provide not only 48 FXS ports, but it also provides an SMDI connection. This is a simple message desktop interface, which is basically a serial protocol used for interfacing with legacy voicemail systems. So if we have an old voicemail system that a customer is not ready to get rid of, you can use one of these in order to communicate back and forth along with the FXS ports, you can use the serial port to communicate where that particular call should go, and then also deal with MWI over SMDI. Okay, nothing that's really on any of your exam, any of the NP exams, not even at the IE level, but just something that's good to know about for real life. Also an AS 5350XM. This can be used for larger deployments or service provider deployments. This can take a very high number of, well, really probably at this point, not even T1s. At this point, you're probably into T3s or E3s in terms of number of voice channels. AS5400XM, again, very large deployments. And 7206 VXR, or the 7200 series of routers, extremely large deployments or service provider edge signaling. So looking at voice and video gateway modes, we've really got three primary modes. We have voice switching. This is dealing with an inbound POTS to an outbound POTS, and we're switching these voice. So there's really no IP involved at all. POTS, as I mentioned, being the plain old telephony system versus PAN's the pretty advanced new stuff. All right, I won't tell that lame joke again. VoIP gateway. So this is a POTS to IP or IP to POTS. And an IP to IP gateway, also known as the Cube or Cisco Unified Border Element. And we'll take a look at all of these. So for a voice switching gateway, we possibly need to convert one type of POTS into another. Maybe we have a PRI and we need to convert that to SS7 signaling. Now, SS7 isn't really something that you need to know for the exam, for any of the exams, other than to know maybe that it stands for System Signaling 7 or Signaling System 7 rather. Okay, predecessor to SS6, and that was the predecessor to SS5. But these are the way that the PSTN and when the telco carriers are not transporting their voice, as many of them are today, using IP, but when they're doing it the traditional digital way, this is done through SS7. So anyhow, Cisco routers can certainly support SS7 signaling. So analog signaling we can use FXO, FXS, E&M, all things we'll talk about. Digital signaling, and we already have talked about really earlier in the CCNA voice modules. Digital signaling, ISDN PRI, ISDN QSIG, SS7. Looking at a VoIP gateway, we possibly have the need to terminate a connection to a PSTN, which is very likely, or even a PBX if we're doing some sort of migration or integration, and convert to or from IP. So again, all of the same signaling protocols minus the SS7. And we'll take a look at IP to IP gateway in a moment. So first of all, let's look at dial peers. There are always two call legs to every gateway. This is very important to remember. It doesn't seem like it's that difficult, but you'd be surprised. A lot of people forget about the inbound call leg. Most no one forgets about the outbound call leg and the outbound dial peer, but many people do forget that there is always an inbound call leg to every gateway. Okay? And therefore, there's always an inbound dial peer. I should say, if we're talking about iOS, there's an inbound dial peer. But there's always an inbound call leg as well. So an iOS voice gateway, this is a gateway. CUCM, that is a gateway. CME, again, pretty much basically just an iOS gateway. They're all gateways. So one of the ways to remember this and to think about it, actually, not just to remember it, but to think about it in terms of some of the other things that we will have and will continue to be taking a look at, such as class of restriction, especially when it comes to iOS or CME in iOS, as well as voice translation rules and things like that, is to think of your own body as the router or the voice gateway, and to think of your two arms as the call legs. Okay, so you're always going to have an inbound call leg on one side and you're always going to have an outbound call leg on the other side. Okay, so use that maybe visual to help you in some of the things that we'll talk about later, as I mentioned, relating to voice translation rules or even digit manipulation when it comes to things like number expansion or class of restriction, core lists, things that we'll talk about a lot more. And again, I'll bring up the 2 call legs, but just something kind of as a preliminary thought to keep in mind. When we're trying to match inbound dial peers, first of all, keep in mind that any dial peer in iOS can be used as an inbound or outbound dial peer. It just depends on the criteria that we have and how well our design, how well we planned, and then how well our design in that planning was set up and then executed. So first of all, if the dial peer is of the type VoIP or it's a digital TDM. So what do I mean by that? Well, first of all, if it is dial peer voice, give it a tag number, and then VoIP. Well, that's dial peer type VoIP. So that's okay. We know that. Good. What do I mean by digital TDM? Well, a time division multiplexing type of PSTN circuit. Okay. So how does the dial peer get that? Well, it's a POTS dial peer. So dial-peer, voice, give it a tag number, and then POTS. But then the port that is attached to it is or happens to be attached or the defining the port number of a PRI or digital CAS, channel associated signaling, all things we're about to take an in-depth look at, or even that the dial peer doesn't have a port defined at all, but that is where a call is coming from. A call is coming from an ISDN PRI or a digital CAS circuit. Okay, so if it is, then we can match POTS dial peers. If it's coming from VoIP, we can match VoIP dial peers. And you might say, well, okay, VoIP, what kind of signaling? Is it coming in through SIP signaling? Because then only SIP dial peers would match. And if it's coming in through H323 signaling, then only H323 dial peers would match. Well, you'll actually be surprised. The dial peer is actually matched based on these criteria before the signaling is taken into account. So if the dial peer happens to be of the type SIP signaling, of the type VoIP, but using SIP signaling, and there's another dial peer that using the criteria we're going to look at also might match the incoming number, but is of the type, well, type VoIP, but signaling H323. So I have those 2 dial peers and they would both match based on the digits coming in, but the actual call coming in is, let's say, signaling H323. I will still match both of those dial peers initially. And if we do a debug VoIP dial peer, we will see that. By the way, debug VoIP dial peer also gives me debug information about POTS dial peers, but anyhow, I digress. It will initially match both dial peers, and then after it matches both of them as potential matches, it will see that the SIP dial peer doesn't match the signaling, and so it will ultimately fail, but it will show up in the debug as a potential match. So be aware of that. In fact, even POTS dial peers will show up as a potential match. So even really anything that matches these criteria are potential matches, and then the type is looked at, and then the signaling beyond the type. So first thing we look at, and this is basically the first priority. So if we see this command configured and it matches, it wins. So if incoming call dash number is configured and it properly matches, either fully matches or partially matches with wildcards, the called number. And sometimes you'll hear me refer to this as called. Sometimes I'll refer to calling as calling. And really the enunciation is just not my inability to pronounce it, but my trying to be very precise with the enunciation so that you don't mistake calling and called. I can say calling and called, and if I say them quick enough, sometimes it's tough to catch which one I just said. Did I say calling or called? So sometimes I'll say calling or called. Or sometimes I'll just say Dinas and Annie. DNIS being the dialed number identification service, and ANI or ANI being the automatic number identification. So DNIS being loosely analogous to called, and ANI or ANI being loosely analogous to calling. So now that I've got that out of the way, incoming called number matches just that, the called number, the DNIS. Answer address, that kind of sounds like called, but it actually matches calling, ANI. Destination pattern, this matches calling, ANI. Now you might say, wait a minute, you're wrong, Mark. Destination pattern matches called number, the DNIS. Well, it does on an outbound dial peer, but we're looking at an inbound dial peer. So destination pattern is the one command that can be used both ways. On outbound, incoming called number can't be used. Obviously, the word incoming kind of alerts you to that. An answer address cannot be used for an outbound dial peer match. Destination pattern is what's used for an outbound dial peer match. But for inbound, destination matches the opposite of what it matches on an outbound. So outbound, it matches called. Inbound, it matches calling. And then if all three of those fail, or else we just don't have any of those configured on any dial peers, then port will allow. But it will only allow for POTS dial peers because, well, we don't have a port for VoIP dial peers. And then there is also the default dial peer. Now, one thing to keep in mind, depending on when the questions for your exams were updated or not, obviously we know that it's a newer version and it's using or representing iOS 15. I'm just letting you know there could be some lingering questions. And again, in any Cisco exam, look for the best answer. Okay, so if you find one that's better, if it says match the 4 potential matches for an incoming dial peer, and it shows you these 5, well, then default dial peer would be the one that would not potentially match because it was removed in iOS 15. But if they showed you 7 possibilities and said match the 5 that could work for an inbound dial peer, and default dial peer was one of them, then it would probably be the other right answer alongside these 4. Okay, so always look for the best answer. But default dial peer, so this is basically dial peer 0, or one that you can't really see and doesn't show up in any show commands, but there is a default dial peer in iOS's before 15.x. And whoops, I went backwards. And the default dial peer is bad. Okay, you should always explicitly configure a matching inbound dial peer. And this is where I'm saying a lot of people forget about configuring an inbound dial peer, and it's the reason for a number of mysterious problems. So this says outbound dial peer. I meant to write down default dial peer, but default dial peer, there, the magic of post-production editing. Default dial peer uses any codec, so any codec is supported and could very well potentially be a problem. No DTMF relay, so guess what? That DTMF is probably not going to get through at all. DSCP 0, so no quality of service. VAD is enabled, and while not always, most of the time, VAD is bad. No RSVP support for call admission control if we needed it. No TCL or VXML applications can be triggered, and no direct inward dial. So default dial peer is bad. Let's take a look at direct inward dialing versus two-stage dialing. So first of all, two-stage dialing. The idea is that a call comes into a gateway, and let's say a call from the PSTN, and the caller then hears secondary dial tone. So they called into your organization, your iOS router picked it up, whether on an FXO port or a PRI or whatever, and all of a sudden, the caller on the other end, out on the PSTN, they hear secondary dial tone. Or I'm sorry, not secondary dial tone, they hear a second dial tone. The same as when they went off hook on their own receiver on their own end. And they're either completely confused, or if they happen to know, they have to dial again to match an internal pattern. And of course, this could very well lead to possible toll fraud. unless this is the desired behavior, this is probably something you never want to allow or rarely want to allow, only in very, particular circumstances. The other method is, of course, direct inward dialing, and the command is direct-inward-dial on the dial peer. So first match the dial peer using one of these commands, and then use the direct-inward-dial command. So the idea here is that a call comes into the gateway, again, let's say from the PSTN, and the DNIS, or called number, is passed on to the router or voice gateway's digit analysis engine immediately. So DID is, first of all, automatic for VoIP dial peers. There's no way not to do DID on VoIP. Automatically happens. DID for POTS is only supported on T1 or E1 CAS, ISDN, and also something called FXS DID. Now you might say, wait a minute, connecting out to the PSTN, that's an FXO port. That's true. It would be an FXO port. However, think about the nature of FXO and FXS. FXO is something that you send information out to the PSTN, and FXO, FXS are basically male-female. So if you have an FXO port on your router connecting to the PSTN, that means that the PSTN, the central office, the telephone company, they basically have an FXS port, right? They have to have basically the opposite. And really what it is they have something called an FXS DID, something that's allowing that information to come into them. Okay. So if you have an FXS DID, then they would have the FXO. This is basically for direct inward dialing specifically. It's really just for inbound dialing. But direct inward dial is not supported on analog E&M, on FXO, or on FXS ports. So if you want an analog port, if it's a digital port, no problem, CAS or ISDN. But if it's an analog port from the PSTN, it needs to be an FXS DID that you have, and you have to get a special type of trunk from them or circuit. Okay, E&M, well, that's typically used for tie trunks or paging or music on hold anyhow, so that's not usually a concern. FXS, standalone FXS, that's usually attached to an analog station, right? One of your analog lobby phones or manufacturing floor phones or elevator lift phones, something like that. So that's not usually a concern. FXO, the way that we take and process calls here so coming in from the PSTN without the ability to do direct inward dial, is through something called connection-PLAR, PLAR being private line automatic ring down. So the idea being we basically say connection-PLAR and then a DN. And then, of course, we have an outbound dial peer that allows for the matching of that DN and the routing of that DN to a particular phone or hunt group, receptionist hunt group or something like that. But that's the idea, is that for FXO calls, we really can't pass them on to individuals in the company. What we have to do is instead pass them all on to a single person, or like I said, a hunt group of call takers. And that normally works out just fine because we typically only have FXO ports, at least in use for primary calls, in very small branch offices or maybe even just small deployments in general. So I've already mentioned this, but just so that it's on the record, matching outbound dial peers uses the destination pattern command, and this matches the called number. So just remember, destination matches called on outbound, and the reverse or inverse, the calling on an inbound. Okay, so let's take a look at iOS dial peer matching in terms of characters that we can dial and, or really not necessarily dial, but use to define our answer address command or our incoming called number command or our destination pattern command. So first of all, we can use all standard DTMF characters. So this is 0 through 9. Also, asterisk and hash, or also called octathorpe, or some people call it pound, But this also includes A through D, A, B, C, and D. And we're actually going to take a look a little bit later in the slides at an actual DTMF keypad, a dual tone multi-frequency keypad. Okay, but there are 4 additional DTMF frequencies that are represented by A, B, C, and D. Now, of course, the telephony equipment, all it cares about is the actual multi-frequency. So the 2 frequencies played together that combine to, create that sort of harmonious new sound. And as soon as it hears that sound, it triggers that DTMF function. But we refer to that as A, B, C, or D. Typically not on any standard telephone keypads unless you happen to have a DTMF tone generator like I do. Sorry. Did I say that? Yeah. Guess a little bit of a nerd. My wife still allows a little bit of the, geek hardware to lay around the house, but most of it's at my office. But yeah, A through D are valid DTMF characters if you did not know that. And we'll take a look at the frequencies that represent those in a little bit. So we can have any of those. We also can, and by the way, so if A through D aren't on a standard keypad, why would we use them? Why are they still there? Well, first of all, they're still there because they were defined a long time ago, and why would we take them out? They're added functionality. Okay, but what would we use them for? Well, let's say one system calling another system, maybe an IVR calling another IVR. Maybe it's not a person on the other end of that line that happens to have a DTMF tone generator, but it's a system, and we want to connect to another system, and we want to play a DTMF character that users cannot dial for, or can't standardly dial. Obviously, it's not super secure because anyone can go buy a DTMF tone generator, but maybe they just don't know to dial it. So we send a particular multi-frequency, such as B, the frequency for B, or the frequency for D, or maybe a series of them, and then that triggers something, maybe another application to occur, or to a call to route to a specific place that a user can't otherwise route the call to. It's very, very useful, actually. So in iOS, a period or a dot, that's a wildcard that matches any single digit. Now, I should go ahead and note, because we can have a pattern that is that keyword we saw earlier, incoming call dash number space dot. That's enough to match any and all phone calls. Now, if a dot only is a wildcard that matches a single digit, how would that match all phone calls, especially calls that had 10 or more digits assigned to them for the incoming called number, the DNIS? And it's a good question. The reason is that while the dot matches a single character, it does not specify that the string, and by the way, phone numbers or DNs, those are strings in terms of programming types. Whenever we deal with programming types, whether it's, not that we'll get into UCCX because it's not part of these exams that you're studying for, but we will get into a similar editor, in fact, almost the same, which is the can't think of it, the Unity Express editor, and we can match information there and various programming types there. But even in iOS, if we're matching programming types or whatever, a phone number or a digit, a DN, is a string. Okay, it's not an integer. It's not a number or an integer in the sense that we don't say, if we have a 10-digit number, we don't say 5,000,263,425. We say 506,203 or whatever the number was that I said. Okay, so it's a string. Anyhow, a single digit or the dot matches a single digit, but it doesn't match the end of the string. Okay, so we'll look at something that we can use to do that, which are regular expressions. But unless we've explicitly used the regular expression that means this must be the end of the string, then effectively we've only matched any single digit. Whether it was the beginning of the string or the end of the string or anywhere in between is up to its own, really not discretion. It's just It's not defined, so it can match any of those. Okay, so incoming call dash number space dot or period, that's enough to match every incoming call. Plus can be used if it's the first character to indicate something we're going to get into quite a lot called plus E164 dialing or full E164 dialing, with the plus character indicating that a country code is what follows. If you use any sort of a GSM cellular phone, which is what most of the world uses except for the US and Japan, then you're probably fairly familiar with dialing plus numbers to dial between countries. The US does use GSM as well. It's just that we also have other carriers that use other radios for cellular, such as CDMA. So anyhow, if it's the first character, then it automatically indicates the plus for E164. There's no need to do anything called an escape. We'll talk about the escape. However, if it's used but not as the first character in the string, then it's a regex or regular expression. You might want to look up regular expressions or Perl regular expressions. Not that they're just dedicated to Perl, but probably where I saw them first many, many, many years ago. But a regular expression is something that we can use to match various types of wildcards. So define, they can be extremely powerful. They can also be a little confusing. Once you get the hang of them, they're amazing. But a plus is a regular expression that indicates one or more of the previous character. So if I had written down a 6 and then I put in a plus, so 6 plus, that would indicate 6, 6. First of all, it would not indicate 6 because it indicates one or more of the previous character. So it would indicate 6, 6, 6, 6, 6, 6, 6, 6, 6, 6, 6, 6, 6, 6, and on and so on and forth infinitely. Okay, one or more of whatever the previous character was. Now, if the previous character was a wild card, like a dot or a period, so I have dot plus, then what I'm saying is for every instance of the digit, and this could be within a string or between multiple strings, but even within a string, every time I find any digit, and by the way, that dot really only represents 0 through 9. So anything 0 through 9, actually it might represent A through D as well. If I did dot plus any digit, so 0 and then another 0, or 1 and then another 1, or 2 and then another 2, any digit can be represented any instance of times over and over. So basically dot plus means any number. Okay, it's really no different than dot, although if you're using, depends on what you're using, but here where we're talking about it, dot or dot plus would really indicate any number. Okay, there are going to be reasons for regular expressions, so I'm not just trying to confuse you. You need to know some of these regular expressions in order to know how we can operate in iOS. Now in CUCM, as you'll see that we talk about later, if a plus is the first character, since it can only be a regular expression, we have to escape it with a backslash first. Okay, but we don't have to do that here in iOS if it's the first character. A question mark is a regular expression that means 0 or 1 of the previous character. And to add a little bit more confusion, a percent sign means 0 or more of a previous character. So if I had, let's just bring up my pen here. If I had, let's see, 5 plus, actually, you know what? Let's use a better example. Whoops, that's not an eraser here. Okay, so just forget about that. I forgot the back of my pen doesn't work as an eraser in PowerPoint. So if I had dot plus, that's going to match any character or any string of digits infinitely long, provided that they have at least 2 digits. Dot and something else, because it represents one or more. has to at least be one more, and then any additional length of more digits. Okay. If I had dot question mark, then that represents a single digit, so 0 through 9, or two digits, because it represents 0 or 1 of the previous character. So it would represent any single digit number 0 through 9, or any two-digit number, and those two digits could be any digits. So 0, 0 through 99. Okay, but it will only represent two digits because it's 0 or 1 of the previous character. So that would be useful, dot question mark, if I wanted to represent 0, 0, actually 0 through 9, and then also 0, 0 through 99. And then percent sign, so let's say I did dot percent, I would probably use this with a specific digit more often, but if I did that, that's going to represent 0 or more of a previous character. Okay, so unlike the plus, which would only represent two digits and then any amount of digits beyond that, so either two or more, unlike the dot question, which would only represent one or two digits, this would represent one or two or more. Okay, so this is two or more. This is one or two. This is one or more. Okay, so something to keep in mind there. Will that get rid of my... Nope, let me get rid of that real quick. Okay, there we go. Now a caret, also called technically a circumflex, but a caret is a regular expression that means the beginning of a line. So if I have a number 206, 501, 5555, by default, that would match not only a string of 206, 501, 555, 55, I think I said enough, but it would also match 206, 501, 5555 if that were the last 10 digits in a longer number. Okay, so maybe there was a 1 at the beginning. It would match. If there was not a 1 at the beginning and it was only 10 digits that began with 206, it would match. If I put this caret there, or circumflex, then it's only going to match if the 206 are the first three letters, or first three numbers. Okay, so the 206, 501, that 2 has to be the first digit. Likewise, a dollar sign is a regular expression that means the end of a line, or end of a string. So if I put 206, 501, 5555, it could be a string of digits longer than that. But if I put caret 206, 501, 5555, dollar sign, well, then it can only begin with 2, only end with 5, and have to have those digits in the middle. So it gives me more control to lock down specifically what I'm trying to match. And believe it or not, we use this stuff a lot. A capital T is special for iOS. It's not a regular expression, but it means wait for the interdigit timeout value to occur, whatever that's set to. Backslash is an escape character so that we can use the next character as a literal character. Okay? So let's see. I'm trying to think of a good example for that. We'll come to an example. I'm actually fairly certain. Bracket, left and then right square bracket, are within there is a range of digits, but it represents a single digit. So I might say left bracket 2 through 9, right bracket. That means any one single digit that is either a 2 or a 3 or a 4 or a 5 or a 6 or a 7 or an 8 or a 9, which inherently or implicitly omits 0 or 1 being an allowable digit for that place. But again, it's only a single digit, and it's a range that can be used for or to represent or to match that single digit. And then parenthesis, open and close parentheses, are a collected pattern of digits. We'll normally use these with some sort of a regular expression. So let's take a look at some examples of pattern matching in iOS dial pairs. So first of all, as I mentioned, incoming called number dot matches every incoming call. I already explained this one as well. Now, if I did incoming called number dot dollar sign, well, then it would only really match a single digit. Okay. Destination pattern dot T, this is going to match a single digit and then wait for interdigit timeout, which means any amount of additional digits. If I just do a dot, while we said it could match additional digits because I don't have a dollar sign, incoming works a little bit different than outgoing, okay? Outgoing is actually going to probably go ahead and route the call. So we put a T there saying, hey, wait for interdigit timeout. Okay, so this matches every call going out to any called number or coming in from any calling number, but with an interdigit timer wait. Destination pattern plus 1, 206, 501, 5111 matches a specific plus E164 number. Here's a good example of the parenthesis in the question. Okay, so destination pattern, parenthesis 206, parenthesis, question. Now what did question represent? We had 3 plus, question, and percent. Plus matches one or more of the previous digit or previous set of digits. In this case, this is parentheses define a set of digits. We'll talk more about sets when we talk about iOS voice translation rules. So you will be using these regular expressions and escapes and other things in a little bit. Right now, we're just talking about dial peers and incoming called number, answer address, and destination pattern. We're not talking about the usage of these special characters in voice translation rules because they do have a few of their own unique rules. Okay, so keep that in mind. But we're just talking about these on the dial peers. So we have a set of digits, which are 206. Plus matches 1 or more. We said percentage matches 0 or more. However, question matches 0 or 1. So question is saying that this previous set of digits, and remember question or plus or percent all say they match, you know, again, the three variations that I just went over, but of the preceding character. However, the character can also be a set of characters or set of digits. So if it's a set, then it's saying this entire set occurred 0 times or 1 time. So what does that mean? That means if it occurred 0 times, it wasn't there, and the number was just 5015111, and that was what was matched, that 7-digit number. If it occurred 1 time, it's saying that it was there. So 206, 501, 5111. For those of you that are in the US or know about or are going to learn about the North American numbering plan, we have pretty much fixed digits unless we're in, let's say, Nome, Alaska, which I actually found out some people in remote parts of Alaska still use 4-digit dialing. But anyhow, in the rest of the US and Canada, don't want to leave them out. Anytime I say the US, I really do mean the US and Canada. North America numbering plan. Mexico used to be included in the dial plan, but they took themselves out. We either have 7-digit dial for local numbers or 10-digit dial for local numbers. Okay, the added 3 digits here at the left, these are what we call an area code, or some people refer to it as an NPA. And then the next 3 would be the NXX. But this would be the NPA or area code, or the rest of the world would call it a geographic or city code. We don't call it a city code because we have many cities that have multiple of these area codes. So that's why we kind of refer to it as a smaller unit of measurement than just a city code. We have some cities that have 13 or maybe even 20 of these area codes, so areas within the city. So anyhow, this matches local calls out to a 10-digit number or the 7-digit variant of that same number, or inbound calling, ANI. Okay, so that can, all of a sudden you see, be really useful so that I don't have to create 2 dial peers, one for 10-digit and one for 7-digit dialing. Destination pattern caret 206 501 $1 matches outbound DNIS or inbound ANI, to or from respectively, either 206, 501, 1, and then any 3 digits, so that entire 1000 series range, so 1000 up to 1999. However, the pattern has to begin with 206, 501, 1, and then it can only have 3 additional digits behind it, because the circumflex or caret says it's the beginning of the string, the $ says it's the end of the string. And then the final example here. Here we have 206, 501, 5, 1 or 2, ... So matches it outbound called or inbound calling from either 206, 501, 5, 1 or 2, and then any 2 digits. So 100 through 199 or 200 through 299, but that's a single digit. Okay? Hopefully that makes sense. That might take going and watching again. I can certainly understand that. It's certainly worth doing so if you think you didn't fully comprehend it and grasp it the first time, because we're only going to be building on that and using, pretty much from here on out, using that as an assumption that you understand that because we've gone over it. So go back and watch it again if it's not crystal clear. So let's take a look at voice gateway failover. And we're going to take a lot more look at H323 and SIP and MGCP as call signaling protocols and really the nitty-gritty details of them here in this slide deck, in this lecture. But I just want to go over gateway failover real quick. So if we have, let's say, a call either inbound, let's say from the PSTN, for instance, or outbound to, with H323 and SIP, there is an intrinsically resilient failover. There's no special failover feature per se. It's just dial peer configuration. Okay, so we simply match those things that we just talked about. So for outbound dial peers, we match destination pattern, and if we have multiple matches, and we do use longest match. So if I have a destination pattern 91 ... and a destination pattern 9 ... and a destination pattern 911, all three on 3 separate dial peers, they all match, but the 911 is the longest. Now there's a way to change that in iOS. That is the rule in CUCM, no changing, but I can change that in iOS, but that is the default, is to match the longest match, the most characters. Just like IP routing, we match the longest prefix or the longest route. Okay? But if I have 3 that are the same, 911, 911, and destination pattern 911 on 3 separate dial peers, well, then they all have equal longest matches, and then we go to something else called priority or precedence. But if they all have equal priority or precedence, then they can hunt between them. And this is where we have automatic failover. Okay? So successive VoIP or POTS dial peers, and again, this is by preference. Even if we have preference, we will, and preferably we do, otherwise we'll sort of load balance between them. But preferably we have preference, then they will be subsequently attempted on the failure of the first or the second, etc. And each call setup is really attempted and treated the same and independently, regardless of types of dial peers. So it doesn't really matter whether it's a POTS or a VoIP dial peer. And therefore, flapping IP links don't really significantly interfere with any sort of call setup operation. Now, as we're going to take a look at, again, I said later in these slides with the details of these protocols, MGCP, or Media Gateway Configuration Protocol, this really does require failover features, especially if we're doing ISDN, which has something called backhauling, and we backhaul the Q931 signaling. All things we're going to take a look at here. But when the call agent is out of contact, so the person, the CUCM that's controlling that iOS gateway, that iOS MGCP gateway, is called the call agent. When it cannot be contacted, then the gateway fails over to what's called local control. And if we have an ISDN-D channel, that has to be reset, and calls are dropped when that resets. So if we have a regularly occurring flapping IP link, This could interfere significantly with call setup. Okay, so just wanted to go over that initially. Well, again, like I said, we'll talk a lot more about those protocols and even the PSTN POTS signaling here in just a little bit. Looking at what is an IP to IP gateway, the industry calls this a session border controller, or SBC. Cisco calls it a cube, or Cisco Unified Border Element. They used to call it an IP to IP gateway. Okay, Cisco's cube is much more than an industry standard SBC. So some Cisco docs, by the way, and debugs actually still refer to this as IP/IP-GW. In fact, upcoming in a series, probably, I don't remember, probably about 30 or so videos from now, something like that, we'll deal with Gatekeeper, H.323 Gatekeeper. And when we do, we'll certainly do debugging. And if an H.323 Gatekeeper is trying to invoke cube, then all of a sudden you will see it talk about IP/IP-GW. Okay, so this is cube. So upon surface level inspection, it appears that it's just what it says it is. It's just another iOS gateway that allows both the inbound and the outbound call legs to be of the type VoIP versus a VoIP gateway. One leg is POTS and one leg is IP. Whether it's the inbound or outbound, doesn't really matter. If it's a voice switch, as we looked at, both call legs or both dial peers are POTS. With cube, both call legs are IP. However, when we dive down deep and see what's actually possible, we find a vast toolkit of functionality. And like I said, we're going to take a lot more of a look at this. Actually, this we won't take a lot more of a look at now. We'll take a look at as soon as, I believe, when we get done with dial plan. Okay, but we will take a look a lot more at cube and what it can do. So let's take a look now at an analog voice circuit review. Some of these things we've already taken a beginning look at and brief look at in your CCNA level video for both analog and digital POTS, but we need to take a much more in-depth look. So FXO, or Foreign Exchange Office, this is used to connect our voice gateway to the central office for PSTN, or Public Switch Telephone Network Services, for both inbound and outbound calls. It uses a 2-wire tip and ring in an RJ11 port, and it provides power, -48 volts for ringing, for call progress tones, which are ringing and ring back, and also dial tone. FXS, Foreign Exchange Station. This is used to connect to an analog device inside a company, such as an analog phone, fax, and/or modem. It uses a 2-wire tip and ring configuration, again in an RJ11 port. Provides something called supervised disconnect. So if one side hangs up and didn't properly inform the other side, the FXS can basically supervise that link and disconnect the call on behalf of the improperly torn down call. And it supports caller ID. So we should be able to, and the FXO supports caller ID as well, but we should be able to see caller ID come across these links, come in from an FXO, in from the PSTN, or out to a caller ID supported analog phone or fax machine. E&M, sometimes referred to as ear and mouth, sometimes referred to as earth and magnet. But E&M can use a 4-wire or 8-wire. And by the way, sometimes this is referred to as a 2-wire or 4-wire. Okay, sometimes it's referred to as a 4 or 8-wire. So the 2-wire, if it's referred to as 2 or 4, the 2 would be equal to the 4 in this 4 or 8. And if it's referred to as 2 or 4, the 4 would be equal to the 8 here. Okay, basically what it's referring to is a 4-wire and 8-wire connection is using 4 wires, the middle pair, or the middle 2 wires for tip and ring for your send and receive, and the outer 2 for what are called the E and M leads. And then if we have an 8-wire, well, then we have 2 E and 2 M leads, and then we have our tip and ring as well. So we are we basically have full duplex signaling. E&M leads or E&M wires handle the signaling. Okay, so if it's referred to as a 2 or 4 wire, they're basically saying the 2 E&M leads, the E and the M make the 2, and then a 4 wire is 2 E's and 2 M's for full duplex. 1 E one way, 1 E the opposite way, and 1 M the one way and 1 M the opposite way. Okay, might be confusing. Just look at how they're defining the question. But these are either in an RJ11, RJ12, or typically they're actually deployed in an RJ45. That's why I say 8-wire port. And they are typically used to connect PBXs together as tie trunks. But they can also be used for paging and for music on hold applications. FXS DID, special kind of FXS that we've already mentioned, can be used to connect to the central office for inbound services only with DID support. So this is, we have maybe a very small office. We don't want to or can't afford to pay for an entire PRI, but we do need, maybe we've got 30 people and they need DID services, but we can't quite justify the cost of a PRI or even a BRI, or a BRI isn't supported in our area. Then we also have another type of trunk that is really just used in North America, called a CAMA trunk, Centralized Automated Message Accounting. This is a trunk service used in North America only to provide special emergency services to a PSAP, and a PSAP is a public safety answering point. So this is basically 911, and the CAMA trunk, we would route our calls over the regular phone lines, FXO, probably FXO. If we had PRI, we probably wouldn't use a CAMA trunk, but we would route information about emergency response locations and other things to the public safety answering point, or PSAP, through the usage of the CAMA trunk.